Good morning, student. Today we'll discuss the mesh analysis. Okay, so consider one circuit. This is 10 volt supply. This is 5 ohm. This is 3 ohm. And this is again 4 ohm. This is 3 ohm. And this is 1 ohm. You have to find this mesh current I1 and this another mesh current I2. So find I1 and I2. We have to find I1 and I2. So we will apply here as this is a loops are there. So whenever there is a loop, we have to apply the Kirchhoff's voltage law. So we will give the polarity to this circuit will be like this. Okay. And this is plus minus plus minus plus minus. So whenever we apply the KVL in this direction, so negative positive, that is a we are going in the direction that is a positive, and after that positive negative, that means there is a drop in voltage. There is also drop in voltage. There is a drop in voltage, and from because of this current, there is a rise in voltage. So apply that. Apply KVL to first loop. Okay. Now we'll start from this 10 volt minus 5I1 minus 3I1 again here minus 4I1, and this one current is coming like this, another current is going upwards. So there is a rise in potential because of this current I2, and this is equal to, so this 5 is there, 3 is happened, 4 is there. Okay, so this is equal to 0. So now we will further solve this 5, and this is a 8. This is minus 12I1. This is plus 4I2 is equal to minus 10. So this is your equation number 1. So again we have to apply KVL to second loop. Okay. So second loop is, we have the second loop like this. Okay. This is 4 ohm. This is 3 ohm. This is 1 ohm. So here one loop was there, and because of that current I1 is flowing like this. This is I2. Okay, so we are applying the KVL to this second loop. So we'll start from this. This is a minus 3I2 minus I2. Again, this is a minus 4I2, but one more current is opposite to this current I2, and there will be the rise in potential because of this current I1. So plus 4I1 and this is equal to 0 because there is no voltage source to this loop. Okay, so 4i1 and this is minus 8i2 is equal to 0. Okay, so we have got these two equations, this equation number 1 and equation number 2. Now we have to solve this equation, and if we solve this equation, we'll get the current I1 and I2. So we'll write this minus 12i1 plus 4i2 is equal to minus 10. This is equation number 1, and this is 4i1 minus 8i2 is equal to 0. So we have to make it this 8 so that it will get cancelled. So multiply the equation 1 by 2. So 24i1 plus 8i2 is equal to minus 20. And this will remain same, 2 into 1. Equation 1 to multiply equation 2 by 1. This will remain same. Okay, now just subtract this. There will be minus 20i1 is equal to minus 20. So this I1 is equal to, here we will get minus 20. So answer is 1. So I1 will, we got 1. Now find the values of I2. So you put this value of I1 in equation number 2, suppose, and we'll get value of I2 here. This 4 minus 8i2 is equal to 0, and therefore minus I2 is equal to minus 4. Therefore I2 is equal to is 4 by 8. Okay, so it is a 0.5 ampere. So I2 is equal to 0.5 ampere. So in this way we can find the current, loop current, by using the loop analysis. Okay, let us consider another example. Example is given. Okay, so this voltage source is 7 volt, and this is 1 ohm resistance, 3 ohm resistors, 2 ohm resistors, 1 ohm resistors, and 2 ohm resistors. So this is okay. So this is a 6 volt battery. Now we have to find this current I1, this I2 and this I3 and all branch currents, and find this I1, I2, I3 and all branch currents. Branch current means how much current is flowing through this branch, how much current is flowing through this branch, like this. So first we have to find this I1, I2, I3, and then we will find this. So give the polarity to this resistance. This is plus minus, this is plus minus. Okay, if you move in this direction, plus minus, plus minus. If you move in this direction now, this is plus minus, plus minus, plus minus. Okay, and now, and in this we have to also move like this. This is plus minus. So now we have to apply the KVL. Okay, to this loop. This is loop first, this is loop second, this is loop 3. So we have to apply the KVL to the first loop. Apply KVL to first loop. So if you go in this direction, so I1, there is a fall in potential, minus sign, minus 2I1 okay. So see, there is a two current flowing. In the same time, this current I1 is also flowing, and this I2 is flowing opposite to this current. So there is a fall in potential because of this current, but there is a rise in potential because of this I2 current. So we can write here plus I2 minus 2 times of I1 plus again there is a rise in potential due to this current I2, because this is a 2 minus 2I1 and this plus 2 I3 and this is a minus 6 volt and this is a plus 7 volt and this is equal to 0. Okay, so we'll solve this further. I1, I2, I1 will take at 1 place, so 3I1 and this is plus 3I3 and this is a plus on this side. If you take here, it will be minus 1. So this is equation number 1. I2 is also there. Okay, some mistake is there. Okay, so I1 is here minus 3, I2 is also there plus 2, I3 and this is equal to minus 1. Okay, so this is equal to minus 1. Now apply the KVL to this second loop also. This is a second loop. We have to apply the KVL to this second loop. Okay, so there is a fall in potential and because of this I2, there is also fall in potential in this resistance, but there is a rise in potential because of this I3, which is coming opposite to the I2. Again, there is a fall in potential in this 1 ohm resistance, but there is again rise in potential because of this current I1. Accordingly, we have to write the equation. So minus 2 I1 minus 3 I1 plus 3 I3 minus I2. This is not I1, this is I2 actually. Current in this second loop. Okay. So we'll just do one thing. Apply KVL to second loop. So this is a 2 I2 minus 3 I2 plus 3 I3 minus I2 plus I1, and there is no voltage source in this loop, therefore we can write like this. So this is I1 is there, I1, and this I2 minus 5 I2, this I3, 3 I3, and this is equal to 0. This is equation number 2. Okay, I1, so I2 is here. Oh, I2 is here, this I2, I2, this I2 is also there, so this will be 6. This will be 6. Again, apply the KVL to the third loop. So this is the third loop. We are applying the KVL to this loop. This is the third loop. There will be the fall in potential because of this I3, but there is a rise in potential because of this I2. This is again, there is a fall in potential in this 1 ohm resistor because of this I3, and again there is a plus 6 volt voltage source is there in this loop. Again there is a fall in potential because of this I3 in 2 ohm resistors, but there is a rise in potential because of this current I1 in this resistance. Accordingly, we have to write the equations. Okay, so applying the KVL to this third loop. So minus 3 I3 plus 3 I2, because there is a opposite current is coming. Okay, again minus I3 plus 6 minus 2 I3 plus 2 I1, and this is equal to 0. So I1 is there, 2 I1, I2 is there, this I2 is there, plus 3 I2, and now the I3 is there. So 5 minus 6, so 6 I3 is there, and this is all equal to 0. This is equation number 3. So we have to solve this equation. Solving equations 1, 2, and 3. We get here I1 is equal to 3 ampere, I2 is equal to 2 ampere, and I3 is equal to 3 ampere. Okay, and now we have to find the branch current. How we can find the branch current? So this is the branch current I1. This is the branch current I2. And what is the current here? It is the difference of these two current, that is I2 minus I3, like this. Here it is also I1 minus I2. Like this, we have to find the current. So I1 is here. I1 is here. So we'll find the current flowing through this 1 ohm resistance. So the current flowing through this is I1 ohm resistance. Current flowing through this 1 ohm resistor. This is I1 minus I3. So I1 is here 3, I2 is here 2, and therefore this is 1 ampere. Okay, direction of current is from top to down. Similarly, we have to find the current flowing through the I2 ohm. So I2 ohm we can directly find it is 2 ampere is given. What is the current flowing through the I3 ohm resistor? Means 3 ohm resistor. I3 ohm resistors. So it is a I3 minus I2. I3 minus I2. So I3 we have got here 3 ampere and I2 we have got here 2. Therefore it is 1 ampere. 1 ampere, and direction of the current is from left to right. Okay, as in the shown in the figure. Okay. So again, what remains now? I1 ohm is 3 ampere. This from again top to bottom, and I2 ohm is equal to I1 minus I3, and is equal to I1 is what we have got. I1 is we have got here 3 ampere and I3 also 3. So 0 current is flowing in the I2 ohm resistors. This I2 ohm resistors. So in this way we can find the branch current as well as the loop current by using the mesh analysis. Thank you very much.